Hi, we're just going to be doing simultaneous equations, and we use simultaneous equations when we have multiple unknowns. Okay, so multiple. So in year 10, it's normally just two unknowns, but in seniors you can have more than two, but normally you do up to three. Okay, so we're just going to be looking at two unknowns. Okay, so copy that and come across. Okay, so if we have an equation with two unknowns like x plus y equals 5, there is an infinite number of solutions. Okay, like e.g. like x, y, it could be 1 and 5, it could be -2 and 7, it could be 0.5 and 4.5. So there's an infinite number, and the reason why there's an infinite number is because x plus y equals 5 is a straight line. So the y-intercept is 5, the x-intercept is 5, and the reason it's an infinite number of solutions is because every point on that line is a solution to x plus y equals 5. Okay, that's why there's an infinite number of solutions. Okay, so then come across. But if you get a second equation, we can actually narrow it down to one particular equation. So this method we're going to call is called elimination, and we'll be looking at two others in other videos. So elimination, we're trying to get rid of something. So for instance, if this is called equation 1 and this is called equation 2, if I add the two equations, draw a line, so x plus x is 2x, plus y plus minus y, the y's are eliminated, so you get nothing, and then 5 plus 1 equals 6, and now you've got a simple equation to solve, so x equals 3, and then we just substitute into either equation 1 or equation 2, it doesn't matter. So we've got 3 plus y equals 5, and so y equals 2. So the solution is x equals 3, y equals 2. And you can easily test that answer in the second equation. 3 minus 2 equals 1, and the first equation 3 plus 2 equals 5. So that's a unique solution. So copy that and come across. We could also have, instead of adding the equations, we could have subtracted the equations, and the x would have been eliminated, and we would have had the y answer first. So it doesn't matter in this particular case which one we eliminated, but can you copy that and come across? Okay, so we're looking at another equation, and I've done it deliberately in that this is equation 1 and this is equation 2, and if I add the equations or subtract the equations, neither of the letters are eliminated because they don't have the same coefficient. But in equation 1, if I multiply everything by 2, I get 4x plus 2y equals 18, and now we have the same number in front of the 2's, and I'll call that equation 3, and if I add equation 2 plus equation 3, 3 plus 4 is 7x, minus 2y plus 2y is nothing, 17 plus 18 is 35, so 7x equals 35, so x equals 35 over 7, which equals 5. So there's our first answer, and then we just substitute that into any of the equations. So I'll substitute it into equation 2 this time for a change. So it's 3 times x minus 2y equals 17. So 15 minus 2y equals 17, minus 2y equals 17 minus 15 equals 2, so y equals minus 1. So the solution is 5 minus 1. Okay? So that's an example where we could not eliminate x or y because they didn't have the same number, but you can easily change one of the equations to either put both have 2's, or if you're looking at x, they both have to have 6's, so you'd have to have two new equations. But anyway, just copy that and come across when you're ready. Okay, so in summary, in the elimination method, okay, so if the original equations have the same coefficient for either of the pronumerals, one or both, you don't have to change the equations. If you've got the same sign for the coefficients, if they've both got pluses, then you subtract to eliminate. and if they have different signs, you add to eliminate. So in the first one, I think we added in both cases because we were killing off the y's. But copy that down and we'll have a look at one more example, or a couple more examples. Oh, no, it's more notes. If neither of the pronumerals have the same coefficient, then you've got to pick one of the coefficients. Pick one of the coefficients, either x or y, to eliminate, and then find the lowest common multiple. Okay, so in the previous one, the lowest common multiple was 2. For x, it was 6. Okay, and then you have to change the equations by multiplying all terms by the same number, by that constant number, and work out if you are adding or subtracting. So we'll look at the next one, and that'll give you an answer. Okay, copy that. Okay, so I'm not going to do the whole thing. Okay, so if you called that equation 1 and equation 2, if I chose x to eliminate, then the lowest common multiple was 6. So I'd have to double equation 1 and triple equation 2 and have 6x plus 4y equals minus 2, and 6x minus 9y equals 3/8 of 24. And this particular case, now I've got the same numbers, I have the same sign, so it'll be a subtract. But if you chose to get rid of y, the lowest common multiple is 6, but it would be 3 times equation 1 and 2 times equation 2, so it would have been 9x plus 6y equals minus 3, and 4x minus 6y equals positive 16, and then these are different signs, so it would have been an add. So it just depends. So here the 6's have the same sign, so I subtract. Here the 6's have different signs, so I do an add. Okay, so you don't need to do that one to finish it off, but that's to finish off it. Okay, and that's the elimination method. Bye.